set up, I will do a brief introduction. I'm very pleased to see such a great turnout today, so thank you all for coming to support our students and your peers. So I'd like to introduce Amanda McDaniel Price. She started our program in 2009, and in the years that she's been working on her degree, she also has been working full-time as a public health nurse for the Fairfax County Department of Health, and she's also started her family during that time, so she has been juggling many different responsibilities, and came to me, I believe, in late September, interested in working on a CE, and she's worked very hard and really jumped very quickly on a fairly steep learning curve. So, you know, I look forward to her presentation today. And she'll be speaking about associations between maternal and placental telomere length and serum concentrations of PCBs and PBDEs among pregnant women after we did a study.
So just to start with some background on a telomere, it's a repeated DNA sequence that's found at the end of a chromosome, and it protects DNA. Some people have compared it to the plastic tip on a shoelace. It shortens as the cell divides, and then there's the enzyme telomerase, which works to add base pairs to the telomere to maintain its length. It's active in reproductive cells, adult germ cells, and it's 10 to 20 times more active in cancer cells. So this is a depiction of a chromosome, and you can see at the end, this black tip is a telomere. So at the top of the graphic is cell division happening, and you can see that as the cell divides, a telomere shortens. At birth, we have about 8,000 pairs, and this decreases to approximately 1,500 as we get into an elderly age. And a cell can divide 50 to 70 times before it becomes senescent, dies, or turns cancerous. Looking at the health significance of telomeres, it's been linked to aging. So as we get older, telomere shortens. It's also been linked to chronic disease, including heart disease and cancer, which are the leading causes of death in the United States. It's also been linked to depression, diabetes, a variety of other diseases. It's also been linked to mortality. Telomere length is affected by genetics, inflammation, and then individual variation is thought to be explained through expression of telomerase during embryonic development and white blood cell turnover rate. Telomere length is an active area of research, and pregnancy is thought to be important. Telomeres do have X-linked heritability, and then pregnancy is also important to look at because there is a susceptibility of disease later in life. That's thought to happen during the interuterine period. Cardiovascular health of the mother, like cardiovascular mortality, has been linked with pregnancy outcomes such as low birth weight. Placental health has also been linked to telomere length, recurrent miscarriages and preeclampsia, for example. And then prenatal stress and types of childhood leukemia have also been linked to shorter telomere length. So looking at determining telomere length, race and ethnicity is thought to play a part. It's been shown in previous studies that African Americans have longer telomere length than other races and ethnicities. And this effect is somewhat mitigated as people get older, and this is thought to be a result of the weathering effect and oxidative stress. As we get older, our telomeres shorten, so age is also a determinant. And then both smoking and heavy drinking have been linked with shorter telomere length. There have been mixed results for socioeconomic status, but education, specifically less than a high school education, has been linked with shorter telomere length. And then lifestyle factors such as obesity and lack of physical activity have also been linked with shorter telomere length. Looking at environmental chemicals, traffic-related air pollution has been linked with shorter telomere length, but particulate matter has been linked with both elongated and shortened telomere length. Other chemicals that have been linked with shorter telomere length include lead and cadmium. Arsenic has been shown to actually elongate telomere length, and this is interesting because it does seem to have a dose-dependent response. So at lower doses, we see increased telomerase activity and longer telomeres, but then at higher doses, we see a shorter telomere effect. Persistent organic pollutants, including PCBs, have also been shown to have a longer telomere effect. So talking about PCBs and PBDEs, the relationship with telomeres has not been well studied. And this is really the first study that looks at PBDEs and telomere length, and it's also the first that looks at PCBs and PBDEs during pregnancy and its relationship to telomere length. Just a little bit of background, PCBs were used in paints and plasticizers and sealants. PBDEs have been used as flame retardants. PCBs were banned in the 1970s, and PBDEs are currently being phased out. Both bioaccumulate. A major route of exposure is through the diet, but for PBDEs, another major route of exposure is through house dust. PCBs are considered a probable human carcinogen. Both have been linked to adverse effects of the endocrine system and neurobehavioral effects. And PCBs have also been linked with negative immune effects. Both have also been linked with negative reproductive effects. PCBs have been linked to decreased birth weight and gestational age, and then PBDEs have been shown to cause thyroid hormone disruption, both in the pregnant mother and in the offspring, and they've also been linked to lower concentration, attention, and IQ. So the main goals of the study were to examine the relationship between maternal and placental telomere length, and then to also look at the association between telomere length and demographics in both PCB and PBDE concentrations. It was anticipated that there would be differences in maternal and placental telomere length, but that there would be a correlation between the maternal and the placental telomere length. And we also anticipated that the PCB and PBDE levels would decrease telomere length. So the study population was 36 paired maternal blood and placental samples from women undergoing terminations in their second trimester at the Women's Option Center at San Francisco General Hospital. Before completing the research project, I did the city training, and all of the protocols were previously approved by the Committee for Human Research at the University of California, San Francisco. And because this data was de-identified, it was not considered human subjects research for GW. To do the data analysis portion, I used Stata, and I started with a variety of exploratory graphics. Because the telomere length was not normal, I used the ladder of power test for normality to determine the appropriate transformation technique. To look at the corollary between the maternal and placental telomere length, I did a Spearman's rank correlation, and this was chosen because of a small sample size and an assumption of non-normality. And then the PCB and PBDE levels were natural log transformed. And then I did a variety of both unadjusted and adjusted regression modeling. Covariates that were evaluated but not included in the final modeling were education, gravidity, parity, and gestational age. And then the ones that were included in the final modeling included age, race, ethnicity, and smoking status. And they were evaluated based on either a previous association with telomere length or statistical significance with a p-value at the 0.10 level. So moving into the results, this is a graph looking at serum maternal telomere length, which is on the left, versus placental telomere length. And you can see that the placental telomere length was longer than the maternal telomere length, and this is to be expected based on what we know about the effects of age on the telomere length. I did want to also mention, though, that we found a positive association between age and placental telomere length, which was not expected. This scatter plot is looking at the correlation between placental telomere length versus maternal telomere length. And as you can visually see here, there really was no association that was seen, and that was something that was not expected. Next, looking at smoking results, we have maternal telomere length here on the top and placental telomere length on the bottom. And although there was not a significant association with maternal telomere length, there was a significant negative association between smoking and placental telomere length. And this is something that has been previously seen in other studies, that smoking causes decreased telomere length. I think this result especially becomes even more significant with what we know about smoking on the effect of the fetus. It can cause premature birth, lower birth weight, and it can also cause birth defects such as cleft lip and cleft palate. And here is a comparison of maternal telomere length on the left and placental telomere length on the right, by race and ethnicity, using as a reference group a combined category of Asian, Pacific Islander, other, and unknown. And what we found was a significant positive association between Latina and Black on placental telomere length. So in other words, among these categories, we saw longer telomere length. And this, again, is something that we have seen in other studies with African Americans having longer telomere lengths. So to increase statistical power, what I did was I looked at Black versus non-Black, and again, this held true. I saw a significant positive association with Black and placental telomere length. So moving into the chemical analytes, on the left is a snapshot of some of the PCB results with maternal telomere length. And I did see a significant positive association between PCB 153 and maternal telomere length. And this becomes even more significant because PCB 153 is the most prevalent in the environment, and it's also the most prevalent in human samples. It's been linked to changes in bone tissue, diabetes, and cancer, and also in terms of pregnancy, it's been linked to lower birth weight. On the right-hand side is a snapshot of some of the PBDE results with placental telomere length. And again, there was a positive association with PBDE 153 and placental telomere length. PBDEs are known across the placenta, and they've also been linked with disruption in spatial learning and memory in animal studies. So, in conclusion, maternal and placental telomere length were not correlated. Smoking and race ethnicity effects were consistent with previous research. And again, with the race ethnicity, I'm talking about that we've seen in previous research, African Americans having longer telomere length. The PCB and PBDE associations were mixed and generally not strong. And further research is warranted. These are just preliminary results that need to be replicated in future studies. So this pilot study was really the first to look at PCB and PBDE telomere length during pregnancy, and no other studies have ever really compared placental telomere length and environmental chemicals before. There's generally a lack of research. We know about health effects of PCBs and PBDEs, but we don't really have a good understanding of what those mechanisms could be, and so this research on telomere length could shed some light on that. And then the results, especially around smoking and African American telomere length, corroborate previous research. In terms of limitations, the human health effects can only be inferred. It was a small sample size. There could be other possible confounders like psychosocial stressors, obesity, that due to a lack of time we weren't able to analyze. And then also on the market, generally these chemicals are found in mixtures, and so there could be interactions that also weren't evaluated in this study. Public health implications of this study, tying into the 2020 Healthy People objectives, include reducing cancer cases and related disability, improving health through genomic tools, and improving cardiovascular health. Having a better understanding of telomere length and its determinants and its role in the disease process can help us improve treatments and increase longer lifespans. Understanding more about the role of PCBs and PBDEs during pregnancy and on human health can also increase our understanding in this area. This study raises concerns about reproductive health, especially the results on the negative association with smoking status. And then the variations among racial and ethnic groups could also be an indication of environmental injustice. So I'd like to thank my advisor, Dr. Zoda, for all of her support and guidance throughout this process. Through her previous research, she had access to the data and provided it with me. And her previous research was done with colleagues at the University of California, San Francisco, the Environmental Chemistry Laboratory, California Department of Toxic Substances Control, and the University of Massachusetts. And their work was funded by the National Institute of Environmental Health Sciences. Questions?
Can you explain about ladder power test and how it compared to other traditional methods to detect telomere length?
Yeah, so I used it, and then what I ended up using for the transformation, I did a natural log transformation for PCBs, and then I did I think it was like 1 over the square root for PBDEs.
No, my question is to detect telomere length. What kind of method used to detect telomere?
Oh, to do the telomere length. Hold on 1 second. It was I didn't actually do it. It was provided to me, and I think it was a ratio. So they had done polymerase chain reaction to yield a TS ratio. Is that
So this is a real-time PCR based or Southern blot? Or
It was PCR based.
PCR based. But how it compared to other methods, like a Southern blot or some other method to detect? Can you compare that, whether it's reliable or not?
Yeah, this is a very standardized method used in the field.
So I wasn't actually the one doing that. The data had already been provided. Oh.
She was first.
Did you use that 90% confidence interval because of the pilot study?
Yeah, there was also a really small sample size, so it was just so that we could detect more.
So I realize your results were confusing in the chemical part of it, but did I understand the results correctly that a positive correlation meant that the more PCB, the longer the telomerase length?
Yes.
Okay.